Hey, sorry. I was so caught up in that whistling of the tune that I completely missed that we were live. I love the intro. Hey, welcome everyone to day 2 of the Firebase Summit. And this is the 5th year we're doing a Firebase Summit, and it's the first time we're having a second day, so I'm really excited. I'm not sure how many of you tuned in yesterday. I know there were a lot of people, but I really enjoyed everything that we had going on yesterday. The keynote was a blast, the Q&A was awesome, and all the technical sessions, honestly, my ears are still ringing. And we have an entire full day of more of that for you, so that's awesome. If you're watching this on firebase.google.com/summit, then you should see all kinds of stuff going on around me. So at the top here, you see links to the on-demand video schedule. So if you missed anything yesterday, you can watch it there, but please stay here for now, do it after we're done. And let's see, there's a live chat going on one of these sites. I don't know which one. And then below here, there should be a Q&A going on. Plenty of Firebases everywhere to answer your questions or just to hang out and chat technology, because that's one of the things we love about doing events. Let's see, what do we have planned today? So we have a full technical track, but the first thing on the agenda is called Zero to App, and that's a live coding talk that we're going to do. So yes, this is really, really live. And we're going to live code it. So when we came up with the idea to do that again, I asked around for volunteers, and the first hand that went up was the one of Paul Ruiz. Paul, can you join me?
Hey, how's it going?
Good. How are you doing today, Paul?
Doing pretty good.
What was your favorite announcement of the keynote yesterday?
Probably the auth emulator stuff.
Same here. I want to get to that. So when we're done with the streams today, I'm totally going to do those. No, I love those. We were waiting for them, right?
Yep.
Hey, Paul, what part of Firebase do you work on?
So I'm actually with the Firebase support team.
Nice. So you are answering a lot of questions from developers about Firebase.
Somewhat. That's mostly our support agents. They do all the hard work. I just am kind of around.
You find the answers to the questions we haven't seen before, right? Yeah. But that's amazing. I love that. We have such a great team at Firebase, including our support agents, who are probably also hanging out in the chat right now. Thank you. Let's see. You signed up for Zero to App, so this is going to be fun. Because I know that just like me, right, one of the things you do a lot is you speak in public quite a bit. How many talks have you done in the past month?
Somewhere around 20 or so.
Ouch. I might have done 3. You were making me feel really bad about myself. But honestly, that number is amazing. I don't think you could ever have done that if you had to travel to all of them.
No, no, not at all.
So there are some upsides to all these virtual events, right? We can attend a lot more of them. Yeah, but there's also some things I miss. Like this morning, I posted a selfie, right? And it's like, I'm not taking more selfies with the folks at the Firebase Summit. I missed that. But also, not sure how it is for you. I often like taking the temperature of the room by doing what I know as a show of hands. Do you know that term?
Yep.
Good. Okay, right. It's like we ask a question. It's like, hey, raise your hand if you've used Firebase before, right? And then we see that half of the hands go up, or right, raise your hand if you like Flutter, and right, then the hands go up, right? And we do this partially because it's good to actually make sure people are paying attention, right? That they know that you are like doing your talk, but also it's really good to get an idea of who's in the room, because then you can tweak your talk, right? If nobody has used Flutter before, then maybe we explain a bit more about how that works. So that's one of the things I really miss. I know, right, you and I started talking, it's like, what do we do for our live coding talk? And we came up with, it's like, we can totally build an app for this, right? Mm-hmm. So we were talking about it, and yeah, that turned into essentially knowing what we want to code, but not coding it. So let's switch to the development machine to see what we have right now. Okay, so this is our development machine. And you see that, well, you see that it's Paul and me doing a talk. You also see that we're going to be doing a demo on firevotes.web.app. You can join that at any time, and we're going to take you through some of the things in the live coding talk. But you also see a phone hidden in the back there. Let's actually look at what we have there. So this is a Flutter application that we have built. And as you can see, it's about the skill level that I probably have with Flutter right now, right? It shows hello world, nothing more. And what we're going to do in the next, let's see, 55 minutes or so is we're going to build this into a show of hands and audience polling app. Paul, do you think that that's reasonable? You think we can do that?
I think we could at least figure it out. So let's see. Probably the easiest place to start is going to be at the beginning. So let's actually open up the code for this Hello World basic Flutter app, which I just happen to have right there. All right, so when we're done, we'll want this app to have a couple of buttons that all of our awesome viewers could use to essentially raise their hands. And I think it would be fun to include some different rounds and a bracket to make this a bit more of a game. So our Flutter app has a few general components that we should be aware of. The main method at the top is where our app is going to start. This is where our My App stateless widget gets created and where we can pass in some general information to our stateful homepage, like app title and theme colors. Since the homepage is a stateful widget, it will also need to have a state object, which is where we'll do the majority of our Flutter work. In that state widget is a build method that will control what our UI shows on the screen. And right now you can see there's just this simple single text widget that says Hello World. So let's actually start off by removing that text widget and adding a new row of buttons. First, we'll add our row widget. This will let our buttons sit side by side on the screen. Next, let's add our first button to the rows children array. We'll start with an expanded widget so that the buttons will fill any available space. And that expanded widget will have a single raised button widget as its child. That raised button will in turn wrap a single text widget. And let's just go ahead and add the word yes to it for now. Great. Let's also add a background color here just to make things look a little bit nicer. So at this point, we can just copy that line and update the color and text over to the word no, and we'll have our second button. Great. Let's see here. Perfect. So we went ahead and saved this file, and then we can actually see that we have something that happened in our app. So one interesting thing to pay attention to here is that this code change, the change has updated the app without having to fully reinstall it. So this is a feature of Flutter called hot reloading, and it allows UI changes to take effect immediately while you're working in your Flutter apps. So now that we're back in our app, we can see that we have our two side-by-side buttons, but you'll notice that they're currently grayed out. You'll also see the same thing if you're following along in our web app. So this is happening because those buttons don't actually do anything yet. So let's go ahead and fix that by connecting these buttons over to our Firebase backend. So this actually seems like a case where the Firebase real-time database is going to be a good bet for both speed and simplicity of the data model. What's important to know about this is that the Firebase real-time database stores data in a JSON structure. So this is pretty much just a tree of values that's hosted in the cloud that our app's going to be looking at. If multiple users are running the app, they'll be looking at the same exact JSON at the same exact time. As far as the actual structure for our data, we'll want to work towards having multiple sections in our database. So that might seem like a lot, but that's totally okay. So let's first write a yes or no vote to the simple votes node here in our database. And then we'll build up to the final structure over a few steps rather than getting ahead of ourselves. We'll also want to look at our Firebase security rules to make sure that this data is readable and writable only by the people that we allow. So honestly, I'm not the best with security rules. So I'm going to just keep this simple for now and just stick to the default version that's going to come with a new database. We can come back to these later once we have more going on with our app. This is also definitely an area where I think we could use some of your help, Puff, to make these a little bit better than I could. All right, cool. So now that we've gone through our database structure and rules, we'll need to make sure that we link our Flutter app and Firebase project together. To do this, we've told Firebase about the package name for our Android app and the bundle ID for our iOS app. Based on that, Firebase has generated 2 config files that we added to our Flutter project. This is actually all done in the console, and we're actually looking at the in-console documentation page for this slide. So you don't need to worry too much about the details right here for now. What's important here is that these config files for our app are how we basically are able to tell it how to find our Firebase project on the server. We've also gone ahead and added our dependencies for Firebase into our Flutter project. So we're doing this using the Flutter Fire plugin here, which you can find out more about over on GitHub. So now that we're all set up with Firebase, let's actually go back to our Flutter project. The first thing that we'll want to do is initialize Firebase in our code. So what this is going to do is it's going to read the config file that we had added earlier and makes all Firebase services available to our project. We also created some fields here for all the variables that we'll need in our app. So now we can create a reference to the root of our database. So since Firebase is cloud hosted, If multiple users are running this app, they'll actually all be pointed to the same exact database. Great. And then for the next task, we'll create a new function called vote that will simply write whatever we pass to it into the votes node of our database. In this case, we'll pass in a simple yes or no based on the button that gets pressed. Looks good. Cool. Next, let's go back over to our build method and update our buttons. By adding an on-press listener to each button, Flutter will actually automatically enable them. Great, so let's go back to our mobile device and we can see that both of our buttons are now enabled. So let's actually take a moment to switch over to our database console as well. So this is the Firebase console for the database. And what you can see here is just the current content of the database. So one cool thing about this is that we'll also show updates live as they happen. So it's a great tool for us while we're working on our app. You're also going to be able to notice that we have a settings node here. This is actually something that we put together specifically for this demo. So we can just kind of safely ignore that for now. Now that we can see our database, though, let's go ahead and try voting. And that should have worked. Let's see what's in the log here. Right. So we actually haven't set up our security roles yet. So users aren't going to be able to vote into our database. So if you see, we actually have this permission denied here, and that should actually pop up as a little snack bar in the web app if you're also following along there. Puff, I think this is actually definitely an area where I think I could use some of your help.
Yeah, I'm not surprised, Paul. I get to do security rules a lot, but this is a great progress on the app already, right? We have the buttons. And one thing I also really like is that you started with a fully secure database, right? Sure, it doesn't make for the best demo yet, but at least nobody can write the wrong data into our database. So I actually think that's a great starting point. Firebase security rules are a bit unusual, but honestly, Firebase is unusual in that it allows you to write from the to the database straight from your Flutter application, right? So we need to do like some special work to make that secure. Let's actually switch back to the slides and see how we are going to make that secure. So here's the data model that we started with, right? We have a single node called votes, and we're going to write yes or no into it. And here you see the default rules that we started out with, right? Nobody can read or write anything to the database. Oh, let's first change that so that everyone can read the votes node. It's not strictly needed, but I sort of think it's a good idea here for the demo. Now, we need to make sure that people can only write yes or no, but we want to make sure that everyone can write yes or no. And we definitely don't want people to write different values to the database because we're showing it in the live stream. So the first thing we're going to do is we're going to add a validation rule. We're going to validate that the new data that is written to the database is a string, and that it's either yes or no. And we could have used a regular expression here, but honestly, I thought this was a bit more readable for today. So with that validation in place, I actually think it's safe to let anyone write to the database. So we're going to set write to true now. And this is the scary moment, of course. Let's publish these rules and go back to the database console and then see if the app now works. Oh, did you see that, Paul? Somebody is beating us to it. So you can see that now when we're clicking the buttons on the mobile app, it's changing. But when we're not clicking it, it's also changing. You see that? That's because the web application on firevotes.web.app is actually also writing this to the same location. But this is great progress, right? Now anyone can write to the database, but we're all overwriting the same value. Like there's only so much value we can get out of a single yes/no toggle. It's mesmerizing to see it change so frequently. Let's switch back to the slides and see how we're going to change the database model to make it more interesting. So so far, we've created this initial data model. But what Paul actually showed us at the start of the talk was that we're going to use this data model. So we're going to store a vote for each user. So if Paul casts a vote, we see his vote. And if I cast a vote, we see mine. And we're going to see them as a list of votes. So we need to be able to sort of like identify that a vote is for a user. And for that, we're going to be using Firebase Authentication. So Firebase Authentication allows you to sign into your application by writing some Flutter code without spinning up any servers. So when you use Firebase Authentication, your Flutter code talks to the Firebase servers to sign in the user, to verify their credentials. And then it gets back a ID for that user, a so-called user ID. And it doesn't matter what device the user signs in on. If they sign in with the same credentials, they're going to get the same user ID. So this user ID is great to associate data with that user. For example, their vote. So let's first change our security rules to actually secure this, because right now we allow everyone to write to the database. We want to change that so that only signed-in users can write to the database. So we're setting a rule that's called auth.uid not equals to null. Now, the auth variable is a built-in variable that's automatically set to the signed-in user on the device that's causing the write to the database. So if we're signing into our Flutter app, then the auth variable will have our credentials in there. And we're checking that this user has a UID. This is automatically managed by Firebase for you. So there's no way for a malicious user to spoof this variable. So it's a great way for us to ensure that the user is actually signed in. Let's go back to the console. And let's have a look at where we are now, because we now have extra security rules. So can we still write to the database? Oh, I see that our error is back. And we didn't make any changes to the code yet. This is really good, because it actually means that we can't write to the database at this point because we've secured our database. This is one of the things I like about server-side security rules. You can make your app more secure without creating a new client-side application. That's really good for situations like this. Cool. Now let's go back to the code so that we can sign up authentication. So we're using Firebase anonymous sign-in here, and we're going to go to our init state to sign in the user. We're using anonymous sign-in because honestly, it's the simplest to wire, because the user doesn't need to enter any credentials to sign in. It just generates a user ID for this user. We wait for that response to come back, and then we're going to set that user into the state so that we can use that for rendering the UI, or for example, for casting our votes. Now, once you're ready to further extend sign-in, you could also add sign-in with Google sign-in or Facebook, Twitter, Microsoft, LinkedIn, all kinds of sign-in providers, or maybe email password, whatever you want. But as said, for the demo, we're just going to use anonymous sign-in for now. Okay, but now when we click the button, let me switch the web demo over. We can see that we can still write to we can write to the database again. So we've done a full circle now, right? We've gone from being able to write for everyone in the world to not being able to write, and now we're signed in so we can write again. So we've made our database a bit more secure. But we're still overwriting all the same data as before. Let's switch back to the slides and look how we're going to change that. So let's update our data model to the one that Paul had before. So we're going to store the user ID for each, or the vote for each user under their user ID. So that means that if Paul is casting a vote, we see Paul's user ID and then his vote. And if I cast a vote, we see my user ID. And if you cast a vote, you will see your user ID. You might not recognize it straight away, but it is yours. So we want to make it so that only Paul can write to his node. And if I write to it, that my write gets rejected. But we also want to make sure that Paul can't write to anyone else's nodes. So we want to make sure that we can only write to the node that corresponds to our user ID. Okay, let's see how that looks in security rules. So this is what we had so far. Everyone can write as long as they're signed in. That's what we need to change. We're first going to actually move all the data one level lower. Because remember, we were writing to votes and then our value. We now need to write to vote and then our user ID and then our value. So you see that we added a level in our JSON in the rules, and it's called $UID. The dollar here has a special meaning, because it means that the rules under this apply to any child node of votes. So this applies not just to one user ID, it applies to all user IDs that we have under there. You can see that we allow the write if auth.uid is not equal to null. We're going to leave the validate unchanged for now, but we definitely want to change that write rule. We want to make it so that the user can only write the vote under their own user ID. Can we go to the next slide? So we're changing the rule to say that you can only write if auth.uid is equal to $UID. And remember, that's the $UID that we also put in the JSON rules, right, in the JSON above. So these two values have to match, right? $UID is the variable that represents the user ID that you're writing under, and auth.uid has to have that exact same value. Okay, if we do that, it means that only Paul can write his value, and I cannot overwrite that one. And I can, of course, write my own value. Okay, let's go back to the code and make the change. Now, honestly, this was a lot more in data modeling than it is in code, because all we need to change now is our vote method. We're going to change it so that we don't just write two votes, but we're going to use the user.uid that we got from the state earlier. And that should be all we need to do to change the data model. Let's actually see if this works. Let's switch back to the console and click the button. Oh, let's open the votes. And I see, Paul, that lots of votes are coming in. I honestly don't know which one is yours anymore, but I'm just casting one on an extra device I have handy here. Right. This is really cool. Thank you for playing along, everyone on the live stream. It's cool to see all these votes coming in. That didn't happen in any of the rehearsals. So let's see. The vote is now recorded in the database. And remember, there's no way that you can vote multiple times. You can change your vote, right? You can toggle from yes to no and you'll see it update, but you cannot vote for anyone else because your vote must be written under your user ID. You can try, but it will be rejected. Okay, I think this is actually pretty close to what we started with, but you know, I'm getting somewhat tired of all this yes and no voting. I really want us to be like a bit more expressive that we can do. So, let's switch back to the console and see if we can come up with something that we can change there. How about we store the values that we want to show in the buttons? How about we store them in the database? So we'll create an options node. And in there, we'll create an array of the values that we want you to vote on. So let's say that we use the colors for now. OK, now we want it to, so that we display these values on the button, because that means that we can change the values without having to change the code. Of course, we first need to make that work in the change of code. And this actually is going to be reading from the database. So let's switch back to slides to see how that works in Firebase. Because we're now going to be using the most unique feature of Firebase's databases, which is we're going to use real-time listeners. With most databases, if you need the value from a database, you're going to like get the value and then just forget about the database. With Firebase, it's different. With Firebase, you're going to attach a listener to a location in the database. And that listener immediately gets the value, just like you're used to. But it then keeps listening. The Firebase SDK actually keeps an open connection to the server, and it waits if there's any updates to the value. And if there's an update to the value, it's sent to your client, to your app straight away. That's what you see in this animation. You see that one of the devices is making a change in yellow, that the change is broadcast out to all other connected devices within milliseconds. And this makes it effortless to build real-time, multi-user collaborative applications, or an audience polling app like we're doing here. Since we can now respond to these changes to the database in our app, this is called reactive programming, because we're reacting to the database. And it's the key to making very interactive dynamic applications. Okay, now let's see how we wire this up in the code. We're going to go back to our init state method. We're going to create a reference to the options node. Remember, that's where we put the array of values. We're going to listen to the value of this node. And this is a stream. If you've done Dart stream programming before, listen gives us a stream. And in that stream, we have a snapshot of the values that currently exist in the database. And since it's an array, it actually is going to be a list of strings in our Dart code. So we get the options from there. And honestly, it's a bit of typecasting that we have to do here. But it's fairly standard. Now, for now, let's actually just print them, because honestly, I'm not very good at Flutter. So let's just print them and see what happens. We got an error. Let's try it again. I think we might have not updated security rules yet. Cool, there's the values that we have. And these are the values from the database, right? Orange and blue, because that's what we entered. And we didn't type orange and blue in, oh wait, we did type orange and blue in the application code. We could have like sneakily gotten it from there. And I know that we didn't. How about we go back to the console and prove that we didn't? Because remember, the code is still listening on the database. So if we change the orange to, let's say, yellow, you actually see that that shows up straight away. And in the web app, you should now have gotten a snack bar with the new values also. Now, this is reactive programming, right? We only wrote one statement to listen to the value, but we get called when that value changes. I think that's pretty nifty, actually, right? Paul, as I said, I'm not good with Flutter. How do we get these values onto the buttons?
I mean, let's take a look. So now that we have our options being populated, we should be able to do something with them. So what we do here is call the setState method in our Flutter code to force the app to redraw with our new data. You'll also notice that we already added 2 strings to our class, option1 and option2. Next, let's go into our real-time database listener and call the setState method. In there, we'll save the values from option1 and option2. Cool. Let's see, so finally, let's go back into our build method and use these options for both our display text and our voting values. One thing to pay attention to here is that we're using these like double question mark syntax. So if our option strings are null, like when we first start up our app and they don't have any data being pulled down and whatnot from the database, then we can just default to these 3 dots as an easy placeholder and more importantly, not crash our app. Looks good. Oh, maybe we are missing a semicolon somewhere.
We are. Got it. Yay, compilers.
There we go. And see, and we can actually see that this is updated in our app as well. So for those of you that are following along, you should also see the buttons in the web app also update. So now that we've refreshed everything, looks good. We actually see yellow and blue instead of our hard-coded yes or no values that we had earlier. So while this works for our most basic functionality, we're still really only looking at one set of possible values. So Puff, maybe this is an area where you can kind of help us flesh this out a bit and make it a little bit more interesting.
For sure, Paul. I am sort of like, I'm a geek. Things must match up. That yellow is driving me nuts because the button is orange. How about we change it back to orange?
Yep. There we go.
Cool, thank you. I see the votes are still going on. That's also really cool to see. I think this is turning into a really fun voting app, right? An audience polling app. Actually, right, everyone can cast their own vote. We can like control the question that we ask. I honestly could see myself using this already in my talks, but I know I'm going to ask multiple questions, right? I'm going to have a few probably yes/no questions at the start, and then some like more questions about, hey, do we do A or B later? And I'd like to keep the history of what I asked and what people voted on. So I think what we need to add now is add some rounds to this. Let's have a look at the data model in the slides for that. Okay, so we're going to move the options into a node called rounds. And we'll give each round a key in there. We'll see what the keys looks like in a moment. But so this way we can store multiple rounds. Now, under each key, we're going to store the values in an array, just like we did before. But in this case, I really like it. We can also show more values, right? So we're going to allow you to add like any number of values in there. And that creates an interesting choice that we have to make, because how do we handle this in our UI? Right? We have like 2 main options, I think. We can either show a button for every option in the database, or we can pick 2 options to fit on the buttons we already have. And for today, we're going to do that last one. We're going to pick 2 out of these options, but you can make another choice. That's totally fine. Now, since we added rounds, we also need to add another layer for those rounds under the votes, right? So remember, we had votes, user ID, and then your value. We're going to change that to votes, round key, and then your UID, and then the value. Now, see that these round keys match up. So we have round 1 key under votes, and it matches with round 1 key under rounds. That's important because it's essentially what a foreign key would be in many other databases. So we are making sure that these keys line up. Then under each round key, we store the value and the UID, right? So for each UID, we store a value. There's an interesting change that comes from this, because remember, you could only vote once so far. But when we do this, you can actually vote once per round. That's exactly what we want, right? If we start a new question, we want to make sure that you can vote on it again. Okay, let's see how we're going to secure these. Let's first look at the rounds. Let's see. I don't think we need to give anyone permission here to read or write. So we're going to set the read and write to false for the rounds. Oh, we're going to set the read to true, apparently, which is also fine. We can all read all rounds. But we're going to set the write to false. And that means that we can't write it from anywhere except from the console. So the Firebase console, since we're logged in as a collaborator on the project, we can make changes there to the database, even if the rules don't allow them. And that is great, because that's what we've been doing so far in the demo. Now, I also want to say something about the rounds. And like I said, when we make changes in the console, it bypasses the security rules, but I still like using them as sort of documentation of my data model. So we're going to say that under rounds, we have a $round. Remember, that's dollar means that it applies to each child node of the rounds node. And then under that, we have $option, which is the options that we have in there, one item in the array. We're going to validate that that's a string, because honestly, that's all sort of that we know right now. But I still think it's useful to have this here. And we're also going to add what I think is a nifty rule for securing the reads. So instead of allowing you to read the entire rounds node, we're going to allow you to only read the last item. But since we're going to be adding rounds dynamically, that last item is also dynamic. So you need to query for it. What this security rule does is it checks whether you're using the right query. Now, the order by key and limit to last, it doesn't really matter what they are all that much right now. We'll see them in the code. But this ensures that you can only read the last round. Okay, so this is the data model that we're going to be creating. Let's make that a bit smaller so that we can use it for reference while we're building the rules below. Oh, I didn't mean to make the slides so smaller. So.
Gotcha.
There we are. That's great. Okay, so remember, we have we have votes, round key, user ID, value. So these are the security rules that we have so far, right? We have votes, user ID, and then the value with the write and validation rules. Let's first add a level for that round key in there. Now we're going to call this $rounds, and remember, that means that it applies to any child key of votes. So we now have two dynamic nested levels here. We have the round key and the user ID. And we need to make sure that these match up somehow, right? So $rounds under votes matches with the round key, and the user ID matches with the user ID. But we want to prevent our database from being overrun with just any votes, right? We need to control the rounds that you can vote on. So we're adding a validation rule here that checks whether the round that you're voting on exists under rounds in the database. You see, we're going back to the root of the database, and we're checking if the round exists there. If they do, the vote is valid. If they don't, your write gets rejected. This way, we have some control over what you're writing in the database. In fact, we have quite a bit of control over what you're writing in the database. Okay, with the data structure decided and the security rule in place, I think we're ready to switch back to the code and make everything work. Now, we are listening to the options node so far. So let's change that to start listening to the rounds nodes, because that's where we now store the rounds. And let's see, we need to listen to the most recent round. So we're going to order them by key. This means that we must make sure that if we add a new round, its key is alphabetically later than the previous key. We'll see that in a moment when we start testing this. And we're going to limit it to only get the last key. And we're going to listen to on-child edit instead of on-value, because we only care about that one child. So let's see, this gives us a snapshot again, just like before. One thing we need now, though, is we need to get the key of that round, because we need that to cast our vote. So we're going to get the current round key from the snapshot. We're going to put that in the state so that we can reference it later. Now we get to probably the most complex line, because remember, we could have more than two options. So we can't just do option 0 and 1 anymore. We need to actually determine which options to show. And I have one thing that I really like. I like having pairs of options. So I like it if we have 4 options that we either show the first and the second, or the third and the fourth. So we're going to do some random magic here. We're going to determine the index of the votes that we want to show, of the first vote we want to show. We're going to do that by getting a random value between 0 and the length of the options we have, dividing it by 2, or actually shifting it left. This gives us a value if we have 4 options as either 0 or 2. So then we set option 1 to either options index or options index plus 1. I hope that makes sense. As I said, this is probably the most complex code. Okay, I think we're ready to get started on this, Paul. Let's switch back to the database console and start making some rounds. Let's actually first get rid of the options because I don't like leaving old data behind. Okay, so we're going to create a new key under the root called rounds. And in there, we're going to create our first round. And as I said, this key needs to be always incrementing. So we're actually prefixing it with a exclamation mark here, which honestly is just something that's very early on in the ASCII chart. Now, in that round key, we're then going to store an array of values. Let's see, let's just do something like numbers here, maybe. Right. Not very exciting yet, but let's see. Okay, I see that the web app on firevotes.web.app is working already, but I think we might still need to restart our Flutter app. There we are. Okay, so now the Flutter app got all options and it's showing option 1 and 2. And if you're on the web app, you either see 1 and 2 or 3 and 4, and you can vote on them. Now this is Firebase. Remember, I can see things happening already. We'll get to the totals in a moment. But I can see people are voting. Let's actually have a look at the votes for a moment also. Ooh, I like this. Do you see the round 1 key? Actually, Paul, do you see we have lots of old votes in there? Let's delete the votes key and let it just recreate for now. Okay, here's the current votes coming in. This is awesome. I like this. And you can see that you're all voting on the actual values. I feel very comfortable showing this data because we've secured our database. We're getting an interesting error, by the way, in the Flutter app. We'll see what this is in a moment. Don't expect to get any more errors there, so we'll see what happens. Paul, how about we do another round? How about we vote on, let's see, how about favorite programming language? That's not at all a contentious topic, right? So let's create a new child key called exclamation mark round 2. And we'll put an array of programming languages in there. Now you see, by the way, that Firebase stores these differently than we enter them. This is how the real-time database stores arrays. Honestly, it's just the fact of how it works. And you can see that the votes are coming in and that we're getting, can you show the votes? For round 2. And we're voting on our favorite programming language, excuse me. That's pretty cool, actually. I actually know why our code doesn't work, Paul. This is definitely a near miss. We've got to change our vote method. Remember, we changed the security rules that you can only write under round.userid, and we forgot to actually cast to a current vote. Let's change that here. Let's write to current round key /userid. That's a lot better. Now let's reload the app and see if we can now also vote without an error message. Thank goodness, no error messages anymore. And I assume that one of these user IDs is ours. Wow, that was a lot. I'm happy that we got everything working. I'm actually quite proud. But Paul, you've been showing that totals key, and I have no idea where it comes from. And honestly, pasting questions into the console is not really scalable. Can you show us how to improve that and where those totals are coming from?
Yeah, so rather than typing in the items that we can vote for every time that we want to run a poll, what we can do is put some preset items in a new script using Firebase's admin SDK. So I'm actually going to switch back over here to the slides. There we go. So here we add some options that we might want to vote on in a Node.js script. So instead of typing them into the console, we predefine them as a list in this script. We've actually initialized the script with a set of credentials too that we've already downloaded from the Firebase console. These credentials allow the script to run with elevated permissions, meaning it can write to our database and bypass the security rules, just like if it were one of us typing directly into the console. And this is the rest of the admin script. So what we do here is we set up a reference to the correct node in our database. select which options we'll use for the option, and then write them out into our database. So for our purposes, the code in the script isn't really that complex, but the fact that we can automate a bit of our database is the main takeaway here. So now that we have this put together, let's go ahead and go back to our database console and see what happens when we run this script. And I'm going to just go ahead and shrink some of this to make things a little bit easier for us to read. And let me switch to our terminal. Great, so it looks like our new items from the script have shown up in our database. So I'm going to go ahead and just expand the new round. And there are 8 options, awesome. So you might also have noticed that these keys look pretty random. So they're actually coming from calls to the push function in our code, which automatically ensures that the generated keys are unique and always incrementing, which is part of why we ended up alphabetizing everything and pulling down the last one. So this is going to be the case even if we have thousands of users writing to them all at once. And then after we ran the script, you can also see that we had that totals node that Puff had noticed earlier. I'll just go ahead and kind of expand that a bit here. Great. So let me go ahead and switch to our slides. You might be wondering where this is actually coming from and how it's being calculated. So this totals node is actually not coming from our Flutter application, and it's also not coming from our admin script. Instead, this is coming from a Cloud function. So Cloud functions are these nice little snippets of Node.js code that you write and that run on Google servers in response to events that happen in your Firebase projects. So for example, when a vote is written to the database, we can automatically run our own code to update a counter somewhere in our Firebase database. Because Cloud functions run in a trusted environment, you can also be sure that only your code can update the totals and not just some random user that's out there. So let's go ahead and take a look at the code that's actually running these nodes. So this is the code that counts the total number of votes in our project. We can see that here that we have the function that is listening for any new votes created within a round. When it catches these new values, they're read into a new variable. And then we create a reference to the totals node where we'll write our new count. And then finally, what this is going to do is it's going to write the incremented value into our totals nodes in that database based on the vote, which is how we actually keep track of which items are ahead of others. So this only runs when the votes are initially cast. If you change your vote, it won't count the new vote. Now, we could change our security rules to only allow casting an initial vote and then rejecting any updates, or we can change the Cloud function to allow the users to change their mind. Either way, between Cloud functions and our security rules, we make sure that the behavior is correct and secure for our use cases. Great, so everything seems like it's working. Puff, what do you think about running a couple polls for everyone that's watching just so we can kind of see how this is going to work in practice?
Oh, I love that. And thank you so much. This actually really helps a lot, right? Between the admin script and the Cloud functions, we've automated a lot of the things that during the talk we were doing in the console. And that is good because we're now going to be running a few quizzes because this might be the first virtual talk of my future, right? So this is the moment I'm going to be using this. Actually, Paul, can you switch over to the web app? And so this is what your web app should look like. You might see different button values, but you should see the same. There's like a show bracket button. Let's click that. Okay, so we're actually running little mini tournaments called brackets over here. So we're showing the results in the brackets. So if you were playing along on the demo, you would actually see that your buttons change much more often than when we put something in the database. And that's because we're automatically starting new rounds. So we're running a tournament over 8 values initially, it seems, and we're asking people which of these two is your favorite. So if you look at the outermost brackets here, you see that on the top left, we have C or C++ versus JavaScript. And on the bottom right, we have Go versus C#. You can see the winner of these two, right? Who won? And the winner of each pairing is moved to the next inner bracket. So there we have JavaScript versus Kotlin, and and Dart versus C#. Now, we determined the winner of that one, and that then made it to the final round. And that's the round that's currently still going on because the final round doesn't end. So it seems that JavaScript is by far the favorite. That's not too surprising in this audience, even though I also like C#, by the way. I love TypeScript and C#, I must admit. So that's awesome. Now we didn't really see what happens. So I'm gonna run the same bracket again, the same thing we did before. Now we're gonna start from the start. So I'm gonna hit enter, and you'll see that it takes a moment, that the bracket now clears. And now we're in round one. So you're seeing one of these pairings and cast your vote. Okay, so we have at least, there's no zero, that is good. I like that. So let's see, Dart is more favorite than Java, that's not surprising. JavaScript wins from C++, Kotlin is very popular, and Go. Honestly, we could have drawn this out on the napkin, right? But let's see what happens if we get to round two. So it's now JavaScript versus Kotlin and Dart versus Go. And just cast your vote. I have no control over this, but the totals function that Paul showed is making this work, right? It's counting these, and you cannot change the outcome of that function because it runs on our servers. Okay, we're almost ready for the final rounds. The final is JavaScript versus Dart. Let's see where we get now. Honestly, this is an interesting pairing because I expect these to be really close. And guess what? These are the two languages that we've been programming today. So I like that too. Now, you might be wondering, how are those rounds created? Oh, that's another cloud function that we built. And we'll share the code for that and everything else we've shown you today in a repo on GitHub in probably the next week or so. Honestly, we just need to clean it up a tiny bit, but the code that you're seeing is all going to be shared, including for the web app that you've been using, including secure tools that we have running there. Okay, so honestly, it really looks close. Dart is getting a bit ahead now, but you can see that this is almost like a tie. As I said, we have no end to this, but we do have some more questions prepared. Let's see, how about, I'd like to know, what is your favorite Google technology of these 8? Okay, so these are 8 Google technologies. They're all pretty popular. Sorry, I just wrote something. And let's see what's most popular. Is it Firebase, Google Maps, App Engine, Android, Assistant, TensorFlow, BigQuery, or Flutter? And all these pairings, right, you're seeing one of these, and you're picking one. In the final, we're all going to be seeing the same one. In round 2, it's Firebase versus Android and TensorFlow versus Flutter. Now, honestly, these are all great technologies, so I won't be hurt no matter what you pick. But we can see that we have 2 clear leaders here so far. While Android had an early start, Firebase and Flutter are now definitely picking up steam. And it looks like we're going to get a final of Firebase versus Flutter. And Paul, definitely cast a vote on our mobile app wherever you can. Oh, this one is interesting. Because honestly, between the 2 of these, this is like peanut butter and jelly, right? These go together so well. So I have no favorite. I'm just going to sum these numbers in my mind and see them as a total vote for the combination of Firebase and Flutter. It's an awesome combination for building scalable, serverless, cross-platform, real-time apps. Okay, Firebase is winning. Thank you, but as I said, I wouldn't be offended by any other result. I see we have a few more minutes, so I'm totally gonna sneak another poll in here, which is, let's see. So this was Google technologies. How about we do other technologies that happened in, I think, the past 50 years or something. So 3D printing, cloud computing, iPad, Uber and Lyft, Alexa, Siri assistants, so all the assistants, iPhone, machine translation, or GPS. These are what I consider breakthrough technologies. And I want to know, what's your favorite? What do you think was most impactful for you personally? And you can see that in round 2, we're now getting cloud computing, Uber and Lyft, the assistants, and GPS. Let's see which are the most breakthrough for me. I was asked this question a while ago, and back then Google Maps was for me one of the main ones, but that might have been a while ago already. So these days that might actually be GPS, right? So, okay, I think we're getting ready for the final round, and it's going to be cloud computing or GPS. And honestly, both are all 8 were breakthrough technologies. This is really cool to see. I see cloud computing, and I'm not surprised. And of course, as a Firebase engineer, thank you. But that's really cool to see. I love that. Okay. I think we have a clear winner here. This is awesome. I have one more question. It's a question that honestly is top of mind of me every day, because I grew up watching a lot of Sesame Street, and I'd like to know, what is your favorite Sesame Street character? We have 8 popular characters here, and I want to know which one you like most of these. Let's see. But we're doing fine. But I'm not sure how we paired these up, Paul. This is really cool to see. But let's see who we get in round 2. The first round is always a bit of a knockout round, right? We get rid of half of the candidates. But now we get Elmo versus Cookie Monster and Count von Count versus Ernie. I love the Count, I must admit. But I like all of these. Also, Cookie Monster, as a web developer, has a special place in my heart, of course. Do you eat cookies? Let's see. So we have 2 leaders here, and it's not close. So in the finals, we're going to get Cookie Monster versus Ernie. That's an interesting pairing, I must admit. Let's see who's winning here. And Cookie Monster is the very clear winner. I am not too surprised about that. That is really cool to see. Thank you so much for telling me who today is our favorite Sesame Street character out of these 8. Thank you. Let's switch back to the slides to take us home. So you've joined the demo in droves. Thank you for that. And you could see that we dealt with that without any issues. We had no hiccups beyond some maybe coding mistakes that we made, but the database worked great. And let's see, how long did it take? We took like 50 minutes and we built the entire app. That's actually pretty cool. Let's see what we did, Paul. We have a few moments left. So we started with a Hello World Flutter app. Then you added 2 buttons to it, right?
Yep.
That's pretty cool, right? And at that point, the buttons were hard-coded. Then we actually started writing to the Firebase database. So we pulled all the configuration, right? We had a Firebase project in the console. We pulled our configuration from there, and then we added it in our Flutter app. Then we started writing to the database. That was good, but we needed to sign in. So we added Firebase Authentication, right? So you use that to add serverless, secure sign-in to your application. This is the amount of code it takes. I've recently actually added Google sign-in and account linking. It wasn't that much more code. Then we started writing that in the right location, right? So we changed the path and location. Remember, it's a JSON database. You determine what goes where. But you secure all of that with security rules. Remember, along the way, every step was secured. We showed you the rules. Let's see, what did we do then? We made it dynamic, right? We started listening for the values that we got from the database. And we wrote those options in the database, and it was auto-updating. For me, this is still the hidden magic of Firebase, because it allows us to make reactive applications. And then we started doing the votes in rounds, right? We made sure that you could have multiple rounds, that we would read them from the latest round, and show those votes, and do the casting. Then Paul explained to us how we can automate some of that with admin scripts, and how we can run automatic mini scripts on Google servers in Cloud Functions. That means that we can do operations that otherwise you can't do from the client, right? Like the code that does the total counting has to be trusted code. You can't leave that to the client. We did that in Cloud Functions. And we showed you that you can do much more magic with Cloud Functions. Paul, I'm actually pretty impressed how far we got. Did you find any big problems in the app we built?
Nothing that I could think of. It seems to be doing pretty good.
Yeah, I think so too. And this is definitely an app that I could see myself using in, I think my next meetup is on Saturday. Are you going to be using this going forward?
Probably, yep.
Yeah, it's fun, right? I really like this. So when is your next talk, actually? I was wondering about that.
I actually got a weekend off this time around. So it'll be the next weekend after that.
That's probably because I'm doing one of the DevFest talks this weekend. So I'm getting ahead of you. Yay.
Yeah, hey, Paul, still a lot of catching up to do.
True. I have, let's see, after this weekend, 16 more to catch up. Hey, Paul, thank you so much for joining us today and building this app together. It's really was a blast to do. And I'm actually quite proud of what we accomplished. Yep. Do you have any plans for the rest of today? Are you going to be watching the sessions? Or are you going to join the live chat?
Yep, I'll be in the live chat and watching the sessions and all of that good stuff.
Cool. Okay. In that case, Paul, I want to thank you again and have a great rest of your day.
All right, you too. See ya.
And that just leaves us to wrap this up. So this was the first session of today, but we have many more technical sessions. In fact, I look forward to taking like a 2-minute break to see if everything's still working around me. And then I'm going to move over to the couch over there, and I'm going to join the live chat to watch the next technical talk. Now, let me think. What was our technical talk going to be? I saw Steve and Karen earlier in a meeting, and they were talking about, wait, I wrote it down. Let's see. I have it in my notes here. Steve kept repeating that he was going to help you iterate your way to a delightful app experience using Firebase Remote Config and A/B testing. That's a long title, but they are going to tell us all about that in a moment here on the same live stream. So don't go anywhere. And no matter what you do next, I want to thank you for joining us at this year's Firebase Summit.
Launching a new feature in your app can be complex and risky. What if something goes wrong? How will you know that your customers are having a bad experience? And how quickly can you fix it? And how do you know that what you're launching is really what your customers want anyway? My name is Steve Wilbur, and I'm an engineer working on Firebase Remote Config and A/B testing.
And I'm Karen Zhang, also an engineer on the team. Today, we're going to share some tips with you on how to use these Firebase growth products in your app development process. We'll talk about how to use Firebase A/B testing to build an experience that your customers will love, and how to use remote config to maintain control of the experience that you deliver. Hopefully, this will help you avoid the dreaded one-star reviews of a bad release and let you sleep more soundly at night.
I'd like to introduce you to a fictional app that Karen and I are working on called Trekker. It's an app that nature lovers like us use to find the best hikes nearby. Whether you're visiting Yosemite and want to find the best route to the top of Half Dome, or just looking for something closer to home, Trekker can be your guide. We're going to talk about how to use remote config to safely launch a new feature in your app. And then we'll use A/B testing to tune that experience to better meet our customers' needs. Trekker is already loved by customers for its ability to curate the best hikes in your area and display maps that you can follow along on your hike. But there isn't yet a way to share that experience with your friends. We think that this will be a great way to unlock some additional growth. We'll let customers review their hikes and then share that review with their friends. We think our customers will love showing off their trips into nature, and the reviews they share will help drive more downloads of Trekker. Let's take a look at testing and launching that feature using remote config. First, let me tell you a little bit about what remote config is and how it works. You can think of remote config as a key value store that lives in the cloud. Those key value pairs are consumed by your app to configure the experience that you want to deliver. We provide SDKs that make it super easy to fetch your configuration, handling things like caching and network issues for you. Remote config also has powerful targeting features that allow you to configure the experience for different customer segments, whether those are by country, language, analytics audience, and more. The first thing we'll do as we code up this new review feature is to set up a feature flag for it. In case you're new to the practice of feature flagging, a feature flag is like an on-off switch that we have in our code that we can control from the remote config dashboard. Having this feature flag gives us the ability to maintain control of the experience our customers are receiving. Perhaps you've had this experience before. You code up a new feature for your app, get the release approved by the App Store, but then when your customers update, they start hitting a major bug. It can take days to code up a fix, go through the review process again, and wait for them to update to the new version. But when we put the feature behind a flag, we can turn that feature off for everyone, or perhaps just the affected users. Let's open up the remote config console and start configuring the feature flag for our new review feature. You can see that there are some existing parameters that we've already set up for this project. We grouped some of those together to help organize configuration parameters that are used together, such as this one that the team used to launch the app's new summer theme. To create the new parameter that will be our feature flag, I'll click Add Parameter. Let's call it Review Feature Enabled. We'll set the default value to false, since we want the feature to be hidden from our customers while we're still testing it. I'll click Add Parameter to save my changes locally, and once I'm ready to make that flag available to my app, I'll click Publish Changes. Now that I've published my feature flag, I can hook it up in my app. I went ahead and got that set up ahead of time, so let's take a look at what the app looks like with the flag off. Sure enough, with the flag off, I do not see any reviews showing up. But now I'd like to start doing some testing on this new feature. How can I make it available for folks on our team to take a look? We can make use of a user property. User properties are attributes that we can set in our app, like a user ID. We can then tell remote config to enable behavior for users that have particular values set. Let's set that up now for our feature flag. I'll go to the User Properties tab in the Firebase console, and I'll create a new user property called username. Now I'll go back to remote config, and I'm going to edit the feature flag we set up. I'll define a new condition, and I'll call it internal testers. And I'll say it applies if the username contains Steve Wilbur. For those testers, we'll want to provide a value of true. And let's save those changes, and then publish. Now that I've enabled the flag for my test account, let's switch back over to the app and verify that it's on. Yep, okay. Now I've got my review feature ready for testing. You can probably imagine some other ways you might use user properties for your internal testing, whether that's putting a debug panel into your app or enabling features for any users that have a company email address. So now let's fast forward a little bit in time. We've finished our testing, and our review feature is ready to get shipped out. Since we're using remote config, we have the ability to do a percentage-based rollout. That is, we can start by exposing the feature to a small portion of our user base. That way we can keep a close eye on our metrics, support channels, and App Store reviews to make sure that our launch is going smoothly. Let's open our parameter and define a new condition to start the rollout. We'll call it Review Feature Rollout. We'll set it to apply for our Trekker app. Then we'll add a condition for user is in a random percentile, and we'll start with 5%. And let's set the value to true for that rollout. Let's save that and publish our changes. And just like that, we've launched our feature to 5% of our customers.
Hey, Steve. We're getting some support emails from customers saying that they're seeing errors when they try to post reviews. I think we might have a problem with our new feature. Do you think we should roll it back?
That sounds like a good idea to me. Good thing we've got this feature behind a feature flag and can use remote config to turn it off while we investigate a fix. Let's go back and edit the flag, and we'll set the rollout condition value to false. We'll publish that change, and just like that, we've gotten our customers back into a good state. No long nights trying to fix the bug or stressing out about getting bad App Store reviews. We were able to use remote config to maintain control of the code we were releasing and keep our customers happy. Next, we code up a fix and get that new version shipped out to customers. Now that it's out in the wild, it's time to give our rollout another go. We don't just want to go back and turn that feature flag on for everyone, though, right? Some of our customers still have that buggy version of our app. So we'll make use of another one of remote config's targeting conditions to limit the versions of the app that we'll enable our flag for. We'll switch over to the Conditions tab and edit our rollout condition. We'll add another criteria, which will be a version condition. The version that we shipped the bug fix in is 1.2, so we will only turn the flag on for this or future versions of the app. I'll save that condition, and then we go back to the parameter and change the rollout value back to true. And once I publish my changes, we've restarted our rollout. As we observe usage of the feature and we feel confident in rolling out to a larger audience, we can go to the Conditions tab and up the percentage. Eventually, we get to 100% and our launch is complete. We'll just want to remember to keep this flag in place to prevent any customers still on that bad version from getting that buggy version of our feature. Eventually, as your customers upgrade, you'll be able to come back and remove this flag altogether to keep your configuration nice and tidy. All right, we've completed the rollout of our new feature. We've been able to track that rollout and see that customers are successfully writing reviews for their hikes. High fives all around. But we see from our metrics that users aren't sharing those reviews as much as we hoped. Well, maybe it's time to do a little experimenting to see if we can get users to share more often. What do you think we should do next, Karen?
I do have some ideas on how to increase review sharing, but ideally I'd like to test out different designs on our users to see which one is the most effective. I think we should run an A/B test, and Firebase A/B testing looks like a great tool to help us do this. Before we dive into setting up an experiment, let's talk a bit more about how the A/B testing product works. Firebase A/B testing allows you to easily test variations of your app on your users to help identify which variation is the most effective at driving the results you care about. Because it is built on top of Firebase Remote Config, very little extra setup is required. You can define your experiment variants simply by setting different values for your remote config parameters. A/B testing's integration with Google Analytics also means that common app metrics such as retention or revenue can be measured straight out of the box. This data is analyzed by the A/B testing pipeline to recommend the best performing variant to roll out to your users. Sounds pretty great, right? Let's try it out. First, we need to come up with some potential improvements to our app. Looking at the review screen, I think that the share button is a bit too hidden in the corner, and maybe that's why users aren't interacting with it. Let's test moving the button to some more prominent locations. So we now have two test variants. In variant A, we've moved the button to the center of the screen, and for variant B, we'll test positioning the button at the bottom of the screen. Hopefully the new placements will draw more attention from our users. We'll code up both these variants in the Trekker app, but because we don't know how users will respond to these changes just yet, we'll put both variants behind a feature flag and disable them for now. All these changes have been released in version 1.3 of the app, and we're now ready to set up our experiment. We're back on the remote config page in the Firebase console, and here we see our parameter defining the location of the share button. This is the behavior we want to A/B test, so let's click on the A/B test button to launch the experiment creation flow. Great! It looks like the experiment name is already auto-populated, and let's add a quick description to remind ourselves of the goal of this test. Next, we will select Trekker as the target app. And since we only want to run the experiment for users with the latest app changes, I'll add a version targeting condition for versions greater than equal to 1.3. Within this target audience, we want a user base that is large enough to get meaningful results, but also not so large to significantly affect app usage if something goes wrong. 5% sounds like a good start. This group will be evenly distributed across our experiment variants. Next, we need to select a metric as our experiment goal. This should be the primary result you want to drive for your app. We want to see more hike reviews being shared. And from the dropdown, it looks like this custom review shared event is already defined and tracked in the app. Perfect. I will select that and leave the additional metrics in place. On to experiment variants. Here, we're going to define the different app experiences we want to show our users. For the control group, we will be keeping the existing behavior, so no change is needed. For variant A, we will enable the feature flag to show the share button in the center of the screen. And for variant B, we will position the button at the bottom. Let's update the variant names to reflect the app experience we're testing, and that's all the setup we need. I'll click on Review to see a summary of our experiment. We're now in the draft view, and expanding on the detail section shows us all our selections from the previous steps. Now's the perfect time to check for typos or make sure your target audience is defined correctly. And it's okay if you notice something or change your mind later. You can always come back and edit the experiment, even after it started running. Everything here looks good to me, so I'll click on Start Experiment. And that's it. 5% of Trekker users will be randomly assigned into one of the three groups, and will see the corresponding app experience the next time their app fetches from remote config. So that was the setup part, and usually you'd have to wait some time for your experiment to run and collect data. But let's speed things up a bit for this video. We'll assume that a few weeks have gone by since we started the experiment, and let's go back to the Firebase console to take a look at our results. We see our experiment in the A/B testing page. Let's click in for some more details. It looks like the bottom share button has resulted in the most reviews shared and is a recommended variant to roll out. Scrolling down further, we can see a comparison of how each variant performed over time against the baseline, and how many users shared their reviews. Looking at this, we can be fairly confident in our results. I think we're ready to roll this out to our users. Let's click on Rollout Variant to update the share button location. The same target audience created in the experiment will be used for the rollout, so this rollout will only affect Trekker users with app version greater than equal to 1.3. We'll rename the targeting condition and review our changes in remote config. Here, we can see that the share button position parameter now has the new condition and new value, and clicking on Publish will deliver this improved app experience to our users.
All right, we've covered a lot of ground together. I think that'll do it for today. We used remote config to feature flag our new review feature. We used remote config's targeting capabilities to test that feature with a limited audience until we were confident that it was ready for all of our customers. We did a slow rollout, which ended up minimizing the impact of a bug that we missed. Hey, it happens to the best of us. We rolled that feature back to give ourselves time to fix it and to get a new version shipped out. Once we completed our launch, we discovered that customers weren't sharing as much as we were hoping. But we were able to run an A/B test to determine a new layout that got us the growth we were looking for. But really, we're just scratching the surface of what you can do with remote config and A/B testing. We didn't even get into things like targeting Google Analytics audiences, making use of the remote config API, or using BigQuery to do deep analysis of A/B test results. So if you want to learn more, you can dig into some of the links in the description below.
We hope you've learned a thing or two that you can use to build something amazing for your customers. Thanks for joining us.
Hi, I'm Rachel.
And I'm John.
We're going to walk through serverless application security on Firebase. Specifically, what features come out of the box and what do you as the application developer need to configure or be aware of?
We will outline how you can secure your app end to end.
First, let's address the pineapple in the room and answer the question, what does serverless mean? In a serverless application, there are still servers, but they're managed for you, in this case by Firebase.
Many people speak of services like Firebase Functions as being synonymous with serverless, but it's much more than that. Serverless refers to any design that leverages third-party tooling or services to replace most or all of the application's backend, which would otherwise need to be maintained by the developer.
Here we have components of a simple Firebase app. Cloud Firestore handles the database interactions, Firebase Authentication makes user sign-ins a breeze, and Cloud Functions handles the compute for our backend interactions. For the remainder of the talk, we'll use a hypothetical shopping app that only uses these components.
The app is pretty simple, but we will review some of its key features and user journeys before moving on. First, a user would download and install the app. When they do that, Firebase will associate the specific installation with a unique instance ID, or IID. This IID is a unique identifier that Firebase can use for things like notifications, analytics, and A/B testing. Additionally, our app will be using anonymous authentication, which is similar to a guest account, but more on that later.
When a user adds or removes something to their cart, we write to a document in Firestore. That triggers a function that confirms the items are still in stock and recalculates the total price. The function then writes back to the cart total and any out-of-stock notifications, which can be used by the client apps. This is a simple, minimum viable shopping app.
We'll spend the rest of the talk discussing the security of our proposed shopping app. We'll talk through what security you get by default and what you need to configure as the developer. We'll end the discussion with a checklist that you can use to audit your own app. To help with all this, we've flown in our favorite security researcher.
Hey, hi John, hi Rachel. I'm Vincenzo, the Vulnerability Vulture. I was just overhearing you explain this shopping app, and I have some questions.
We thought you might. Let's jump in.
My first concern is that I like to use a client or SDK code that is open source. If I have to include proprietary code, it doesn't have the benefit of having lots of eyes on it that can help spot security problems.
We believe that our SDKs should follow the principle of open design. This is the idea that security should be addressed by correct implementation and review processes, and not by hiding the source code from would-be attackers. Because of this, most of our SDKs are already open source. For the parts that are not yet open source, we are actively exploring how to decouple them from proprietary dependencies so that we can release them to the public as soon as possible.
The SDKs are doing a lot of work to provide an idiomatic and convenient interface, and we recommend using them. If for some reason you can't or you have implementation concerns, you can always fall back and use the REST API directly.
That's really good to hear. I don't want to use code I can't see, you know? The next thing I think about when I look at this app is that I want to protect myself against a malicious actor. What kind of DOS protection do Firebase services like Authentication and Firestore provide? How will my Firebase services handle an attack?
Good question. Let's first explain some terminology to the folks at home. DOS, or DOS, stands for denial of service. The traffic from a DOS attack is meant to flood a system or application with so many requests that it can't respond to requests from real users. This is bad. If our users can't shop, we can't make money with our app. Since traffic goes up as a result of denial of service attacks, your bill could also go up. If you suspect an attack on your application, reach out to support as soon as possible and let them know what's happening. However, Firebase does offer some protection against this scenario. If your service has request spikes, often quotas will kick in and automatically throttle traffic to your application. This throttling protects both your application as well as other applications being hosted on shared infrastructure.
Wow, John, this is great information. But what about Firebase functions? What specific denial of service protections are offered there?
Great question. Functions handle this kind of traffic differently because they're built to auto-scale to the limits that you set. If you set a max of 10 concurrent functions, for example, a malicious actor couldn't run up your bill too high. They could probably deny service to your legitimate users, though, because functions wouldn't scale to service those real users. When you're getting used to functions, almost everyone DOSes themselves if they don't try out their functions locally before they deploy them. For example, the function in our app listens to the items subcollection of the cart, but suppose I set up the listener to listen to the cart itself. An item could be added to the cart, and then the function would run, which would write back to the cart. That would trigger the function to run, and that would write back to the cart, and so on.
If this happens to you, remove the function and redeploy once you have fixed the issue. Depending on the magnitude of the mistake, you may still want to reach out to the support team to let them know what has happened. To mitigate the risk of DOSing yourself, use the Firebase emulator suite to test the flow of your app locally before you deploy your functions.
That's great advice. Returning to malicious actors, if you're really being DDoSed, traffic will generally trigger an API level restriction that will block a lot of the traffic before it's added to the quota for your app. The structure of your functions can also be defensive. For example, say I have an app that lets users hit a +1 button to like something. Instead of triggering my +1 function every time a user likes something, I could write those to a pub sub queue and have my function run periodically to consume and roll up those triggers that have taken place, and now they'll happen in one read-write operation. This reduces the real-timeness of my app, so I don't want to use it for everything, but it's an option I want to have in my back pocket if I'm worried about abusive traffic.
Wow, that's great information. Now let's talk about Firebase API keys. With other API keys, I'm very protective of them. I keep them in environment variables or a vault specifically made for secrets, so I never expose them in the code. But with Firebase API keys, I don't just put the keys in the code, I put them in the client code, where anyone could see them. Is this safe? Does this let a malicious actor make requests as if they're my app?
Many services use API keys as both a user identifier and as a key, so it's very important not to share them. That's fortunately not how API keys work in Firebase. The Firebase API key only lets us know which Firebase application the client should be making requests to. It's made to be included in the client and does not need to be kept secret. Access control to your data and storage depends entirely on the security rules you've configured for those services, not whether or not you have an API key. Additionally, you can set up API key scoping. This ensures that your API key can only be used when paired with your app's specific headers. This helps provide a bit more defense in depth by creating more obstacles for an attacker who is attempting to spoof requests.
I should also mention here that your API key is different from your server key, which is used with services like Firebase Cloud Messaging. This key is meant to be kept secret and should not be confused with your Firebase API key. So let's update our checklist with some of these action items.
Wow, this is really good to know. Let's talk about security rules. I know that security rules are the configuration I can write to set access controls for my database or storage buckets. Are there any real consequences if I don't do that?
If you're using Cloud Firestore, Firebase Storage, or real-time database, you should always pay attention to your security rules. Default Firebase Storage rules allow access to all of your stored objects by default. Preferably, change your rules to deny all access until access is needed. Real-time database and Cloud Firestore both offer default rule options. We highly recommend that you create your databases in locked or production modes respectively in order to leverage the principle of having fail-safe defaults. These modes mean that by default, no access will be granted. You can then adjust your rule sets to allow only the access that is needed as it is needed. These security rules are what will prevent malicious actors from having access to your entire database, so allow access sparingly.
Aha! A malicious actor could read out all your data, back it up somewhere, and then delete it from your database. This is called a ransomware attack, right? Attackers in this scenario usually then ask for payment in order to return your own data back to you.
Exactly. Don't leave yourself open to that. Always configure your security rules.
Okay. How should I go about writing my rules? How do I know if I've done it correctly?
Great questions. Some people leave writing their security rules until the end, after they've written the rest of their app, but that can make it more difficult. Think about security rules as a kind of schema for your application. It's a record of who can access the different kinds of documents in your database, and potentially data validations for the fields as well. Writing rules as you add features is the best way to go. When you make changes to start writing to a new kind of document, also write the rules for who should be able to access that document.
When writing your rules, keep in mind the principle of least privilege. That is, don't allow access that isn't required for your app to function. Read and write are broad permissions. Instead of write access, you could granularly specify create, update, or delete permissions. Instead of full read access, you could specify single document permissions.
Setting read-write if auth is not equal to null at the root of your rules is not an adequate rule, especially if you're using anonymous authentication. Remember that an anonymous auth, a UID, is created for anyone who starts using your application, so this check will be true for all users, and letting them read or write to anywhere in your database is dangerous. As for knowing if you've done enough, we recommend using the Firestore emulator to write unit tests for your security rules. Test that your rules allow the access that you want and disallow the access that you don't want. We've just released a new code lab on local first development that walks through test driving your security rules. And check out the talk by our colleague Yu Chen about setting up CI to use those tests. Links for all of that are in the talk description. So we have a few more items for our checklist.
Wow, thanks. This may sound like a funny question. Do I need to write rules for my functions?
Not funny at all. Functions take actions similar to the client code, but the difference between them is that functions run from a trusted environment, whereas client requests are executed from an untrusted environment. Because of this, we do not need to set security rules on functions. If you are integrating with an existing server full system, you have the option of setting up your own server to communicate with the Firebase backend directly. If you choose to use this tactic, we recommend that you use the Firebase admin SDK. The biggest difference between the admin SDK and the other Firebase SDKs is that requests from the admin SDK are implicitly trusted, meaning that requests bypass your security rules entirely and are always granted access to your data. This allows you to deploy very strict rules while still maintaining access to your data.
Cool, thanks, John. Okay, we've taken some steps to guard against malicious users. I also worry about how I'm authenticating my users. If I have app security without user security, it's like I built a big fence around my nest, but I left the key out for anyone to use. Let's talk about user security in Firebase.
Firebase Authentication is Firebase's product for managing users. Authentication is the backend, and we have the Authentication SDK and UI libraries that can streamline development on the front end. A lot is ready to go out of the box, but you still want to be thoughtful about how you're using Firebase Auth. The best practice is to either use managed auth using an OAuth 2 provider or custom auth if you have an existing way of signing in users. Our OAuth options use a variant of PXE, the industry standard. For custom auth, you'll make your own JSON Web Token, or JOT for short, and then you'll do a one-time exchange for a Firebase JOT to get those users into Firebase auth. Firebase JOTs are short-lived, but they can't be revoked. If you accidentally issue one to somebody, they'll have about an hour of access. Issue JOTs from a trusted environment that you control, not from client code. Our colleague Kevin recently published an example of how to do this using Okta as the identity provider. And check out the talk from Sam and Malcolm that will go into more detail about custom authentication.
If you are starting a new app, we recommend using one of the managed auth options. Not all the options have the same level of security, but sign-in providers that use OAuth 2, like Google Sign-In or Sign-In with Apple, are currently the most secure. If you use email and password sign-in option, it's important to have your users verify their email addresses. If you don't, you are open to account creation abuse. This can make for a terrible experience for your users. Additionally, set quota limits for user sign-in attempts. This will prevent attackers from trying to brute force account passwords. This limit can be set in the Google Cloud Console. Real users can always use the forgot password flow if they truly can't remember their password. I should also briefly mention multi-factor authentication. There's currently not a free option for multi-factor authentication provided by Firebase. However, upgrading to Google Cloud Identity Platform lets you enable SMS as a second factor. It's a bit more expensive, but may be worth it for you. So let's update our checklist.
Wow, this is all great to know. You mentioned this app is using anonymous authentication, but the words anonymous and authentication seem contradictory. What is the use case?
Anonymous auth is our version of guest accounts, and the most common case is for a warm onboarding. You can start saving user information before the user creates an account. Anonymous auth is basically improved session data. Data persists through opening and closing the app, but if a user loses their phone or clears local storage, there's no way to reestablish the link between that user and the user ID that you have in your database. So convert users to a sign-in method other than anonymous authentication before you save data that they'll want back when they lose their phone. Anonymous authentication also comes with risks. Anyone can create an anonymous user on your app, so write your security rules with that in mind. You could use security rules to gate certain documents to only be accessible for users that have an increased level of security. For example, the first rule here only allows access if the user is not using anonymous auth. The second one is an example of only allowing access if the user has verified their email. So we have some authentication items to add to our security list.
Awesome. Thanks so much for clearing up authentication. I've heard that some of the most effective hacks have been accomplished by hacking the account of company employee. How do I limit my team's access to information and functionality?
This brings up another secure design principle: separation of privilege. People should only have access to sections and instances of your app where they need access, and only a very limited number of people should be granted global permissions. This way, one compromised employee cannot result in full access for an attacker. Many employees can develop locally, purely within the emulator suite or within a dev instance of your app. Limit these employees to local access. A staging version of your app is often the next layer of isolation within a deployment pipeline. Using this strategy, we can set up a flow of development from dev to staging to production, while isolating the access to each layer. For those that do need production access, be sure to use granular Firebase permissions or create custom IAM rules for further isolation. To be clear, security rules should be the same across all environments, but your production data is almost always the highest value target.
Wow, thanks. That really helps. I've also heard of some hacks of well-known libraries that started doing mischievous things. What should I do to protect my users in case there's a hack of one of my open source libraries?
You're right to be concerned about open source libraries when they have a new and perhaps less trustworthy maintainer. Also watch out for libraries that are published as a slight misspelling of a popular module. In one instance, a new maintainer of a popular NPM module started to steal Bitcoin. This problem is hard to be alerted to if you're running code on your own machine, and it's even harder if it's running in a function. So what can you do about it? First, there are some libraries that alert you to vulnerabilities in your code. One of those is linked in the description. You can install it as a test or a development dependency, and you can make sure that you don't have a vulnerability like this before you deploy your functions. One of the worst case scenarios is a cloud function that starts doing something very compute intensive in the background. And the good news is that this can't really happen. When your function returns, the CPU for the function is throttled down to 0. So any compute that someone would be trying to do on your dime would only work for as long as your actual function is working.
That being said, it's still always a good idea to set up monitoring on your functions. Firebase Functions is directly integrated with cloud logging, which lets you monitor the invocations, runtimes, and memory usage of your functions over time. You can even configure alerts on specific thresholds.
Wow, that's great to hear. Firebase Functions have a lot of configuration that I can set. How do I know what the right quotas are? If my function is complex, I don't want to set too low of a timeout. For other functions, I'm worried about how to handle sensitive information.
Let's start with how to handle sensitive information in functions. In a server full app, you would normally put the most sensitive information into environment variables, but that's not how it works in functions. You should never put sensitive information into environment variables. The best option for most cases of sensitive data is to encrypt that data. But if you have an extreme case, you have the option of putting the function into a virtual private cloud, or a VPC for short. And you can set up a VPC connector that still lets your function be triggered by outside services like your client apps. To figure out what the right configuration options are for your new function, monitor the function's performance to get a sense of what's normal for compute time. Setting up alerts for when you're getting close to your quotas will also give you a heads up if you're starting to go viral and you want to raise your quota, or if something's going very wrong. Check out the new video by our colleague Todd called How to Turn on Billing and Still Sleep at Night. Links to that and to the documentation are below in the description.
Creating simple functions can help mitigate some of the risk here. Complexity in your functions can often lead to hard-to-spot bugs or result in unexpected behavior. Just remember, simple is almost always better.
Good point, John. We'll finish the checklist with these final items about function security. To wrap up, security is definitely different in serverless architectures, but Firebase is bringing you the tools that you need to create secure serverless applications. This is a priority for us, and we're building new security features all the time. If you have an app that you need to audit, or if you're starting a new app, use our checklist to make sure that you're doing your part to keep your Firebase app secure. The checklist, along with all of the references that we made in the talk, are linked in the description below.
Woohoo! I can't wait to finish my roadkill delivery app. A free possum with every order. Thanks for all the information.
No. Thank you, Vincenzo.
Do you want to create your own recommendation engine in your app to recommend content to your users based on their interests? I'll show you how to do it in 5 easy steps. Hello there, I'm Ibrahim from Firebase ML, and welcome to adding on-device recommendation to your app with TensorFlow and Firebase. I have an app that recommends movies. Up until now, I hand-created recommendations to my users as I didn't have the data science skills, and I didn't know how to build a personalized recommendations engine. I also didn't want to use a cloud recommendation solution, as I prefer to keep my users' data private on their device, keep the solution lightweight with low latency, and have the feature work even when the network is offline. Creating a custom ML model typically involves these 5 steps. First, identify the business problem. In this case, creating movie recommendations. Second, gather, pre-process, and split data. In this case, it's gathering the analytics reflecting a user's content interest. Then, pre-processing it to be able to feed into the model, and splitting it into training and test data. Third, create a model architecture. Fourth, train, tune your model, and evaluate it with the test data. And finally, deploy and implement your recommendations engine. Today, I'll show you how to do it, all of that, using Firebase and a few other tools. By the way, this tutorial and other reference code labs are available at codelabs.developers.google.com, so you can access the source code and run the tutorial at your own pace. Let's get started. Here is my app. As you can see, I have a list of movies where our users can show their interest using the like buttons. They can then go to the recommendations tab to get a list of movies they might be interested in. Currently, the app is working, but I'm not showing any recommendations. At the end of the code lab, I will implement the recommendation engine and present the recommendations. As a first step, I want to gather data, so I'll go to Firebase console and enable Firebase Analytics for my app. With Analytics, we would like to obtain user behavior data. In this case, which movies or users like in a sequential order. This data will be used in future steps to train the recommendations model. Now, I go back to my app and add this code snippet which will trigger an analytics event each time one of our app's users likes a movie. We'll send the movie's ID in a select item event. Later, when we aggregate these events, we'll draw conclusions on which movies or users are likely to watch after showing previous interest in a group of other movies. Now that we added this snippet, our app will start sending analytics data back to Firebase. Note that there may be a small delay before the events show up in console. In the meantime, you can use debug view to test your event. Now that my events are coming, I need a place to store and aggregate this data where I can query just the right part to feed into my model. Wish there was a tool for it. BigQuery comes to the rescue. BigQuery is a Google Cloud product that allows you to examine and process large amounts of data. And it has a great integration with Firebase. In this step, you will connect your Firebase console project to BigQuery so that the analytics data generated by your app is automatically exported to BigQuery. We'll go to Firebase console, click Settings and Project Settings. From the Integrations tab, we'll click BigQuery. We'll select Analytics Events and Accept. You have now enabled your Firebase console project to automatically send Firebase Analytics event data to BigQuery. This happens automatically without any further interaction. However, the first export that creates the analytics dataset in BigQuery may not happen for 24 hours. After the dataset is created, Firebase continually exports new analytics events to BigQuery into the intraday table and groups events from past days in the events table. Training a recommendations model requires a lot of data. Since we don't already have an app generating large amounts of data, in the next step, we will import a sample dataset into BigQuery to use for the rest of this tutorial. Let's import sample dataset into BigQuery. We'll go to BigQuery dashboard in the Google Cloud Console. We'll select our project name. We'll click Create Dataset. Let's enter Firebase Recommendations dataset for the dataset ID and Create Dataset. The new dataset shows up in the left menu under the project name. Let's click it. We'll now create table. For Create Table From, we'll select Google Cloud Storage. In the Select File from GCS bucket field, we'll enter the path of our sample dataset. For our example, Firebase Recommendations Test Formatted Data Filtered TXT. We'll select JSON-L in the File Format dropdown. Let's check the box for Auto-Detect Schema and input parameters. We'll enter Recommendations Table for the table name and select Create Table. Now we can explore the sample dataset. We'll click on the dataset and the table we just created and select Preview to see the actual analytics event data this table contains. Now we will create service account credentials in our Google Cloud Console project to access and load our BigQuery data from the Google Colab environment in the next step. First, we'll enable the BigQuery, BigQuery Storage, and Firebase ML APIs. Then, we'll go to Create Service Account page and create a new service account with owner role for this example. Our browser will download the key. In the next step, we will use Google Colab to import the BigQuery data, pre-process this data, train our recommendations model, and export this model in TF-Lite format, suitable for using mobile apps. In the Colab, let's run the first cell to clone the TensorFlow recommendations model sample from GitHub. This is the model we will use with our analytics training data to create the recommendations model. The model uses a convolutional neural network encoder. It applies multiple layers of convolutional neural network to generate an encoding of the user history analytics data. Hey, if you're a mobile developer like me, you can just use the steps below as is, without any previous machine learning experience. But if you do want more details, you can simply refer to the documentation for the underlying TensorFlow model. In this notebook, we use analytics data from BigQuery to generate training data for our recommendations model. To access BigQuery data from the notebook, we'll upload the service account file that we just downloaded in the previous step. Let's start with a test import for only 10 rows. We can see that Firebase Analytics exports a lot of additional information, such as device type, platform version, that we don't need for the purposes of training this model. The fields we are interested in are event name, timestamp, items, and user pseudo ID. Notice that some fields, such as item fields, are actually an object. We'll extract the subfield to create the item ID. Here, we can give it a try. Now, let's import the whole dataset with only the fields we are interested in. So far, so good. Now, we can move to the pre-process stage. We'll start with the lambda function to extract item ID and rename it as movie ID. Now, we can safely drop the items column. To train our model, we would like to create a timeline of movies for each user. So, we'll group these events per user and sort them using the timestamp. Finally, we'll convert these timelines to training and testing data. We'll skip timelines less than 3 IDs and pad all timelines up to 100 IDs. Finally, for testing, we'll expect our model to infer the latest movie after seeing all the previous movies in each timeline. We'll go ahead and write these examples into TF records to be loaded in the training step. Now, we can start training our model. Here, we are only training 100 epochs to speed up training time. But you might want to use increased number of epochs to trade longer training time for a higher quality, higher accuracy model. There are multiple types of models you can use for recommendation, from a bag of words model to an RNN model or a CNN model. In this example, we use a CNN model as that is suited best for our particular dataset and use case. But refer to the code lab for more details selecting a model for your use case. This may take a little more than an hour to train, so I'll fast forward. But hey, if you really want to see this, let me know in the comments below and I'll shoot another video. Here we go, we are at the latest epoch. In the next step, we'll compress and export our model into a TF-Lite file so we could actually use it on mobile devices. As you can see, our model export was successful. We can see our TF-Lite file under the export directory. Let's give it a quick try and make sure the model file actually works. Oh, here it is. Now that our model is ready, the best way to deploy it on the fly is using Firebase ML. We can easily upload the model using Firebase Admin SDK. Let's initialize our app instance. First, we'll upload the model file to our cloud storage bucket. Then, we'll create a model object with the name recommendation. Finally, we'll publish this new model so it's available to be downloaded from our app. Now that our model is on Firebase ML, we'll go to our app and add the model download snippet. Here, I'm checking if the model is downloaded before. If not, I'll create a download task, and when it is successful, I'll access the TF-Lite file. With the TF-Lite file downloaded, I can initialize my interpreter. Let's make sure our model name is the same as we name it on our publishing step, which is recommendations. As you can see, here we are loading the movie names into our app to be able to label the results. For our inference to work as expected, I'll convert users liked movies into a similar timeline with paddings, just as we train the model. This will be our pre-process stage. And I'll simply run my interpreter in the inference stage. For our model and the inference stage, all our movies were given as integer IDs. So the result will also be an array of movie IDs with corresponding float numbers of confidence. In the post-processing stage, I'll simply match the labels, in our case, the movie names, with the movie IDs. Let's run our app and see if it works. Here, as I move to the recommended tab, I get the message that my remote model is downloaded. So, let me like a few movies, and here are my recommendations. Beautiful. Just to make sure, I can go back and change my likes and come back to brand new recommendations. Today, we were able to build a recommendation engine from scratch by training our own TensorFlow model in Colab. To achieve that, we gathered data in Google Analytics, processed it in BigQuery. Finally, Firebase ML helped us to deploy this model to our device. You can go further ahead. Monitor your model's performance with Firebase Performance Monitoring. Pick the most accurate and performant one using A/B testing. You can check our digit classifier code lab for those steps. You can also create a continuous training pipeline, running the training steps we used at Colab, instead in a cloud environment. We can't wait to see what you can achieve with Firebase ML. Please check out the docs linked in the description to learn more about these tools, as well as the tools we covered in this video. And hey, if you'd like us to do another video on more of these tools in the future, let us know by liking the video and subscribing to the channel. And maybe we'll be back with a part 2. I'm Ibrahim from Firebase ML, and goodbye for now.